Hello friends, good evening. Myself Path Trivedi from Chanakya Academy, and today we are going to discuss about chapter number 5 of 12th Science Mathematics, Continuity and Differentiability. Basic concept of continuity we have studied in 11th Science in chapter number 13, Limit and Differentiation. Here we need to study more about continuity. What is continuity? Suppose any function is given to you and you have been asked that whether you need to check whether that given function is continuous or not. We have studied different type of functions in 11th Science, Relation and Function, chapter number 2, like Modulus Function, Sinum Function, Greatest Integer Function, Least Integer Function, Constant Function. So here in this chapter we need to find out that whether given function is continuous at that given point or not, or sometimes whole set will be also given to you that we need to check function is continuous on that particular set or not. First definition of continuity is that suppose f is a real function and C is a point in the domain of f, such that if f is continuous at C, then limit x tends to C, f of x must be equals to f of C. This is the main condition for any function that must be continuous at that given point. Here that given point is C. That means these conditions we have studied in 11th Science also, that left hand side limit of that given point, right hand side limit of that given point, and value of that function at the given point. If all these three values are equal, then we can say that given function is continuous at that given point. Let us check for one example. In our textbook, example number 1 is that check the continuity of the function f of x equals to 2x plus 3 at given point x equals to 1. First of all, we are going to check left hand side limit of that point. Here for left hand side limit we need to denote that point by negative sign, as well as for right hand side limit we need to denote that term by positive sign. Here negative and positive sign doesn't mean that is x tends to minus 1 and x tends to plus 1. Negative sign indicates that limit x tends to 1 from left hand side, and positive sign indicates that limit x tends to 1 from right hand side. That doesn't mean negative and positive. Remember that. So here limit x tends to 1 minus f of x we are going to check first. So here only one function is given, that means we need to take that function for all three cases. Whenever we are going to put that f of x, it will be limit x tends to 1 minus 2x plus 3. We can put limit then and then only if the given function is not equals to infinite, or we can also say that we can put limit then and then only if the function is defined function. By putting x equals to 1 in this equation, 2x plus 3, it will be 2 into 1 plus 3. 2 into 1 plus 3, that means that is equals to 5. Suppose that is our equation number 1. Now second point, for right hand side limit. So for right hand side limit only one function is given, 2x plus 3. That means again it will be limit x tends to 1 plus 2x plus 3. By putting that limit of x, it will be 2 into 1 plus 3. 2 into 1 plus 3, again it will be 5. Now third point, that is value at the given point. Value at the given point, here given point is what? X equals to 1 is the given point. So function is given f of x equals to 2x plus 3. So 2x plus 3 as it is. Instead of x, now we need to put that point. Here point is x equals to 1. So f of 1 equals to 2 plus 3, that is equals to 5. Give that equation number 3. So here from equations 1, 2 and 3, we can say that all values are equal and that is equals to 5. So function is continuous at x equals to 1. Now suppose we are taking another example from our textbook of NCERT 12 Science. This is example number 2. Check the continuity of function f of x that is equals to x square. F of x equals to x square at the given point x equals to 0. So what we need to do first of all? Again we need to do the same process. First of all we need to find out left hand side limit of that function. Here left hand side limit of the function that can be written as limit x tends to c minus. Here instead of c point, that point is given to you, that is 0. So limit x tends to 0 minus f of x. Now instead of f of x, which function is given here? X square. So instead of f of x we need to put x square, and x tends to 0, that means it will be 0 square, and 0 square equals to 0. Suppose that is our equation number 1. Similarly now we need to find out for right hand side limit. Right hand side limit that is indicated by limit x tends to 0 plus f of x, and instead of f of x again it will be x square. X square that means 0 square, and 0 square that means 0. So suppose that is our equation number 2. Now value of the function at that given point, that is f of x. F of x equals to x square is the function, and point is given here is x equals to 0. So value of the function at point 0 will be f of 0 equals to again 0. So here we can clearly see that from equation 1, equation 2 and equation 3, f of x, left hand side limit of f of x, right hand side limit of f of x and value of function at point 0 all are same. So from equation number 1, 2 and 3 we can say that f of x equals to x square is a continuous function at given point, that is x equals to. Suppose our next question is example number 4 from our textbook. Show that f is not continuous function at x equals to 0, where f of x equals to given to you, that is, see here, instead of one function it is given here two different functions. First function is x square plus 3 whenever x is not equals to 0, and f of x equals to 1 whenever x is equals to 0. What does it means? It is clear that whenever value of x we are taking equals to 0, then we need to put value of function f of x equals to 1, and whenever we are taking other value of x than 0, then that function will be x square plus 3. So for two different limits, left hand side limit and for right hand side limit, our function will be x square plus 3, as well as for the value of function at the given point, value of f of x will be 1. So first of all we are taking here left hand side limit. Left hand side limit is indicated by limit x tends to 0 minus f of x. So it will be left hand side limit, instead of function x tends to 0 minus, that means value of x tends to 0 but it will be less than 0 because that limit is left hand side limit. So value of x will be less than 0. So function is x square plus 3. By putting the value of x, it will be 0 square plus 3. So answer will be 0 square plus 3 equals to 3. Now for right hand side limit. For right hand side limit, that means limit x tends to 0 plus f of x. Here function is given, that is x square plus 3. So again it will be 0 square plus 3, and 0 square plus 3, that means 0 plus 3 equals to 3. So that will be our equation number 2. Now for third case, that is value of given function at the given point. Here function is f of x, f of x, that is given by x square plus 3 as well as 1. Now we are taking value of the function at the given point. Here point is x equals to 0. So whenever we are taking x equals to 0, then answer of function will be 1. So here f of x, whenever we are writing, that means f of 0, value of function at that given point, and value of function at that given point is already given, that is 1. So we need to write down that 1 directly. So here we can say that whenever x equals to 0, then function's value at x equals to 0 will be 1. So now we can clearly see that from equation 1, 2 and 3, in equation 1 and 2 answer was 3, and in equation number 3 answer is 1. So from 1, 2 and 3 we can say that these three values are not same. If these three values are not same, then we can say that function is not the continuous function at that given point. So here given point was x equals to 0 and given function was f of x. So we can say that function f of x is not continuous at the given point x equals to 0. Suppose our next question is example number 10 from our textbook. Check the continuity of the function f of x. F of x is given by x plus 2 whenever value of x is less than or equals to 1, and f of x equals to x minus 2 whenever x is greater than 1. So here it is indicated that whenever value of x is greater than 1, then we need to take function as x minus 2, and whenever value of x is less than or equals to 1, then we need to take value of function as x plus 2. First of all, we are checking for left hand side limit. Here left hand side limit is given by limit x tends to 1 minus f of x. 1 minus f of x, that means value of x will be less than 1, and if value of x is less than 1, then function will be x minus 2. So it will be limit x tends to 1 minus here for value of x which is less than 1, that means value of x will be less than 1, so function must be x plus 2. So limit x tends to 1 minus, it will be x plus 2. By putting the value of x, it will be 1 plus 2. 1 plus 2 will be 3. Give that equation number 1. Now for right hand side limit will be indicated by limit x tends to 1 plus f of x. 1 plus f of x, that means right hand side limit of that point 1 plus, that means value of x will be greater than 1, and for greater than 1 value function is x minus 2. So here we need to put function as x minus 2. By putting the value of x, it will be 1. So 1 minus 2 will be minus 1. That will be equation number 2. Now it is clear from this point already that here we can clearly see that in equation number 1 answer was 3, and in equation number 2 our answer is minus 1. So from 1 and 2 directly we can say that these two values are not same, and if these two values are not same, then we can say that function is not continuous function at that given point. So here f of x is not continuous at x equals to 1. Now let us move to the exercise. Question number 6 of exercise 5.1 is of similar type. Here we need to find out all points of discontinuity. Discontinuity, that means at which points function is discontinuous function. We need to find out. First question is f of x equals to 2x plus 3 whenever x is less than or equals to 2, and second function is f of x equals to 2x minus 3 whenever x is greater than 2. So now first of all we are going to take left hand side limit of f of x. and left hand side limit of f of x, that means value of x must be less than 2. Must be less than 2, that means here function will be what? 2x plus 3, because whenever x is either less than or equals to 2, we need to take function as 2x plus 3. So by putting that value, limit x tends to 2 minus 2x plus 3 will be there. Now value of x tends to 2, that means instead of x we need to put 2, so it will be 2 into 2 plus 3 will be as it is, so our answer will be 7. Give that equation number 1. Now second, we are going to find out right hand side limit. Right hand side limit, that means limit x tends to 2 plus f of x. X tends to 2 plus, that means value of x will be greater than 2, and for greater than 2, which function is given here? That is 2x minus 3. So instead of function f of x, we need to put 2x minus 3. So limit x tends to 2 plus 2x minus 3. By putting value of x here, that is equals to 2, so it will be 2 into 2, 4, minus 3 will be as it is, so answer will be 4 minus 3 equals to 1. So again, from equation 1 and 2, we can clearly see that equation 1, value of function was 7, in equation 2 it was 1, so this both values are not equal, so we can say that f is discontinuous at point x equals to 2. Now our next question is question number 8 from the same exercise. F of x is given here, modulus of x upon x whenever x is not equals to 0 and whenever x is equals to 0, function is 0. So first of all, we are going to check for left hand side limit. Left hand side limit is given by limit x tends to c minus instead of c, which point is here given, that is 0, so limit x tends to 0 minus f of x. Now here we can clearly see that one value is given for x is not equals to 0 and another is for x is equals to 0. So x is not equals to 0, that means x will be either greater than 0 or less than 0. So here for left hand side limit, value of x tends to 0 minus, that means value of x will be less than 0, and value of x will be less than 0, then we have one function which is known as modulus function that we have studied in 11th, that modulus of x becomes negative of x whenever x is less than 0. So by putting that value in the given limit, it will be limit x tends to 0 minus f of x equals to limit x tends to 0 minus, instead of mod x it will be now minus x upon x will be as it is, so x will cancel and answer will be minus 1. And we know that limit for constant term, that is only constant, so limit for minus 1 will be minus 1 as it is, and that becomes our equation number 1. Now suppose we are going to find out limit from right hand side. So from right hand side, that means limit x tends to 0 plus f of x, and we know that whenever value of x is greater than 0, then modulus of x will be equals to only x. So by putting that value in the function here, it will be limit x tends to 0 plus mod x by x, and instead of mod x it will be only x by x, and value of x by x both will cancel out and answer will be 1. So limit will be equals to 1. So we can see that from equation number 1 and 2, first value was minus 1 and now second value we have found that is equals to plus 1, so that both values are not same. So we can say that function is discontinuous function at the given point, and here given point was x equals to 0. Suppose we are taking next question, that is question number 10 from the same exercise. Function is f of x equals to x plus 1 whenever value of x is greater than or equals to 1, and second function is given, that is x square plus 1, and that is whenever value of x is less than 1. According to our process, first of all we are going to find out left hand side limit. That means limit x tends to 1 minus f of x. 1 minus f of x, that means value of x tends to 1, but due to that left hand side limit, value of x will be less than 1, and value of x is less than 1, then we need to take which function? Second one, that is known as x square plus 1. So by putting that function over here, it will be limit x tends to 1 minus x square plus 1. Now function is defined function for x tends to 1, so by putting that value of x here, x is equals to 1, that means 1 square plus 1 will be as it is. So 1 square plus 1, that is 2. So our answer is 2. Give that equation number 1. Now for right hand side limit can be written as limit x tends to 1 plus f of x. 1 plus, that means value of x tends to 1, but that will be more than 1, or we can say greater than 1. And for value of x which is greater than 1, we have one value of function, that is x plus 1. So whenever we are taking right hand side limit, value of function will be f of x equals to x plus 1. So by putting the value of x again, it will be 1 plus 1 equals to 2 again. Give that equation number 2. Now third, see, we are finding here third value of the function at that given point. Why? Because value of equation 1 and equation 2 both we got same. If both values are not same, then from the two equations directly we can write down that here limit x tends to 0 plus f of x or 1 plus f of x, that is not equals to limit x tends to given point from negative side. So from that two equations we can write directly that function is discontinuous function at that given point. But if we got two values equal, then we need to go for third step. And third step is we need to find out value of function at the given point. So here point is x equals to 1 point. So value of function at point 1. Value of function at that point 1, x equals to 1. So function we need to take, that is x plus 1. So x plus 1, that means here 1 plus 1. 1 plus 1 equals to 2. That means equation number 3. So we can say from equation number 1, 2 and 3, from equation number 1, 2 and 3, we can say that there is no point where the function is discontinuous. So in other words, we can say that f is continuous function at x equals to 1 point. That was question number 10. Now suppose we are going to find out for question number 7. See, in question number 7 is important one for board examination also, because it contains two questions in the single question. As we have discussed earlier, up to this particular question number 10, all points was given that was only a single point, like point x equals to 1. In previous example, x was equals to 0. In previous example, continuity we need to find out for x is equals to 2. But now in this question number 7, here we can easily see that more than 1 points are given to you. That means value of function for, first of all, x is less than or equals to minus 3 is given. Value of x whenever that is in between minus 3 and plus 3, that is also given. And whenever value of x is greater than or equals to 3, that is also given. So here if we are going to see clearly, then we can see that two different points are given. One point is x equals to minus 3 and another point that is x equals to plus 3. So we are going to find out for that both points differently. So here two different points are given, that is x equals to minus 3 as well as x equals to plus 3. Suppose we are going to find out first of all for x equals to minus 3. So limit x tends to minus 3 minus. Now here you need to see clearly. See, the value of a point is minus 3 and we are going to find out left hand side limit. So it will be x tends to minus 3 minus, and instead of function it will be what? X tends to 3 minus 3 minus, that means first function we need to take, that is mod of x plus 3. So by putting that function over here, it will be limit x tends to 3 minus mod of x plus 3. Instead of x, value of x here is minus 3, so it will be minus 3 into mod plus 3 as it is. Now minus 3 mod, that will be plus 3, and plus 3 as it is, that means 3 plus 3 equals to 6. Give that equation number 1. Now suppose we are going to find out right hand side limit for minus 3 point. Right hand side limit for minus 3 point, that is limit x tends to minus 3 plus f of x. And whenever value of x is tends to minus 3 but from right hand side, that means x will be more than minus 3. And here which function is given for x is more than minus 3? That is given to you here is minus 2x. We can clearly see that whenever value of x is in between minus 3 and plus 3, that means value of x is more than minus 3, then function will be minus 2x. So by putting that function over here, it will be limit x tends to minus 3 plus function will be minus 2x. Now value of x tends to minus 3, that means minus 2 will be as it is. Instead of x, it will be minus 3. So minus 2 into minus 3 becomes plus 6. Give that equation number 2. Both values of equation 1 and 2 are same, so we need to find out value of function at that given point. Now value of function at that given point, that means value of function at point minus 3, and we can see that whenever we are going to take x equals to minus 3, then function will be equals to mod of x plus 3. So f of minus 3 equals to mod of minus 3 plus 3 equals to 6. So from equation number 1, 2 and 3, we can say that given function is continuous function at given point x equals to minus 3. Now for second point, that is x equals to plus 3. We are taking limit, left hand side limit of that point, that is limit x tends to 3 minus f of x, and whenever left hand side limit we are taking, that means value of x tends to here 3, but it will be less than 3. For less than 3, which function was given here? It was x will be less than 3, that means we need to take function as 2x minus 3 minus 2x. So by putting that function over here, it will be limit x tends to 3 minus 2x. Minus 2 will be as it is, and value of x will be here 3, so answer will be minus 6. Give that equation number 1. Now whenever we are taking right hand side limit, that means here value of x tends to 3 plus, that means which function we need to take? 3 plus, that means last function is here 6x plus 2. 6x plus 2, by putting that function over here, it will be limit x tends to 3 plus 6x plus 2, and instead of x, whenever we are putting that 3, answer will be 6 3s are 18 plus 2, that is equals to 20. So here we can clearly see that from equation number 1 and equation number 2, both values are not same, and if both values are not same, then function is a discontinuous function at that given point. So it is very easy to find out that whether given function is continuous or not. Now suppose next question is question number 17 from the same exercise 5.1. It is given that, see, till this question we have discussed about the continuity or the discontinuity of the given function, but this question is different from that. It is given that find the relationship between a and b if function is continuous at x equals to 3 point. Here you can see that it is already given that function is continuous function at x equals to 3. So what is the condition for continuous function? If given function is continuous, then we can say that left hand side limit, right hand side limit, and value of function at the given point. all must be same. You need to remember this thing properly. I am repeating this. If function is continuous at given point, then left hand side limit, right hand side limit and value of function at given point all must be same. Here it is given that f of x is continuous at x equals to 3. Here both different functions are already given. For x is greater than or equals to 3, which function is given here? Ax plus 1. And for x is less than greater than 3, bx plus 3 is also given. So by putting both values, for left hand side limit function will be ax plus 1, for right hand side limit function will be bx plus 3, and by comparing them it will be by putting the limit a into 3 plus 1 will be as it is, on other side right hand side b into 3 plus 3 will be as it is. So a into 3 will be 3a plus 1 will be as it is, b into 3 will be 3b plus 3 will be as it is. Now by simplifying terms, by taking all the terms on left hand side, it will be 3a minus 3b plus 1 will be as it is, plus 3 on this side will be minus 3 on right hand side. No terms will be there, no terms, that is equals to 0. So 3a minus 3b minus 2 equals to 0 will be our final answer. If we are going to take 3 common from first two terms, then it will be 3 into bracket a minus b, and if we are taking that negative 2 on other side, it will be positive 2. So value of a minus b will be equals to 2 by 3. If we are taking b on other side, then b will be also positive, so value of a will be equals to b plus 2 by 3. So in this way we have derived the relation in between a and b from the given condition that function was continuous at the given point. It is very easy. Suppose our next question is question number 23. Continuity of f of x equals to sin x by x whenever x is less than 0 and x plus 1 whenever x is greater than or equals to 0, we need to check. So first of all, we need to take left hand side limit for the function, that is limit x tends to 0 minus f of x equals to limit x tends to 0 minus as it is. For 0 minus, which function is given here? Sin x by x is given, so it will be sin x by x. And we have studied this relation in 11th standard that limit theta tends to 0 sin theta by theta or tan theta by theta, that both was equals to 1. So by using that relation here, limit x tends to 0 minus sin x by x, that is equals to 1. So give that equation number 1. Now for right hand side limit, that means for value of x which is greater than 0, function is given here x plus 1. So by putting that function over here, value of x will be equals to 0 plus 1 will be as it is, so answer will be also 1. And whenever we are going to find out value of function at that given point, that means here point that is x equals to 0, and whenever x is equals to 0, we need to take x plus 1 function. So answer will be x plus 1, that is 0 plus 1 equals to 1. So from equation number 1, 2 and 3, we can clearly see that f is a continuous function at x equals to 0. Now in the same exercise, if we are going ahead, then from question number 26 to 30, all questions are of similar method. In all that particular questions, it is given that all functions are continuous at the given particular points, and we need to find out the value of k which is given in that particular functions. Suppose 26th question we are taking. Here value of f of x is given, that is k cos x upon pi minus 2x whenever x is not equals to pi by 2, x is not equals to pi by 2, that means either x is greater than pi by 2 or x is less than pi by 2. And another value of function is given at x equals to pi by 2 is f of x equals to 3. So it is clearly here given that function f is continuous at x equals to pi by 2, and if function is continuous at x equals to pi by 2, then we can see that left hand side limit of that function, right hand side limit of that function, and value of the function at given point all must be same. So by putting the value of left hand side limit here, left hand side limit or right hand side limit, both will be having the same function, that is k cos x upon pi minus 2x, and value of function at pi by 2 point is already given, that is 3. So we need to put that is equals to 3. So now what to do with this equation to find out k? First of all, k is constant, so we can take that outside from that particular limit, as well as we are taking 2 common from the denominator. Why we are taking 2 common from the denominator? Because in numerator we can see that cos x is given, as well as in denominator 2x is given. So to convert that 2x into x, we are taking the 2 common. So by taking 2 common from the denominator, therefore answer will be here k by 2 will be outside the limit, as well as limit x tends to 0 will be the x tends to pi by 2 will be there. In numerator cos x will be there, and in denominator we have taken 2 common, so first term becomes pi by 2 from that pi minus as it is, and second term becomes x instead of 2x, because we have taken 2 common from that must be equals to 3 as it is. Now if we are going to take that denominators to on other side, then it will be in numerator. So already 3 is there in numerator on right hand side, that 2 will be going on that side also, so answer of right hand side will be 6. So on left hand side only k will be there. It will be k into limit x tends to pi by 2 cos x now can be written as what? We all know that cos x can be written as sin pi by 2 minus x. Why we are converting into sin pi by 2 minus x? Because we have one relation. Whenever theta tends to 0, sin theta by theta equals to 1. So here the same relation we have created. Value of x tends to pi by 2 is there. So in numerator sin pi by 2 minus x. So if value of x tends to pi by 2, then value of pi by 2 minus x tends to what? It will be 0. So it will be sin theta by theta. So we can see that it will be k into 1 that is equals to 6, and if k into 1 that is equals to 6, then final answer of k will be also equals to 6. See next question. F of x is given here that kx square whenever x is less than or equals to 2, and f of x equals to 3 whenever x is greater than 2. So here we can clearly see that function is continuous at x equals to 2. So left hand side limit, right hand side limit, and value of that given point all must be same. That means limit x tends to 2 minus. Why we are taking 2 minus? Because it is given that whenever x is less than 2, function will be kx square. So that will be left hand side limit, and value for x is greater than 2 is equals to 3. So on right hand side we are directly taking that 3. So by putting the value of x here, x is tends to 2 minus that means from left hand side, but value of x will be 2. So it will be k into 2 square that is equals to 3. 2 square that is equals to 4. So k into 4 that is equals to 3. So value of k will be equals to 3 by 4. That is very simple. Now suppose we are taking next question, that is question number 28. Now question number 28 is f of x equals to kx plus 1, where x is less than or equals to pi, and f of x equals to cos x whenever x is greater than pi. Here it is given that function is continuous at x equals to pi. It is given. So left hand side limit, right hand side limit, and value of that given function at that given point all must be same. Now by putting that values, left hand side limit whenever we are going to put, function will be kx plus 1. Right hand side limit whenever we are going to put, function will be cos x. By putting value of x is pi here, so left hand side will be k into pi plus 1 will be as it is. On right hand side it will be cos pi, so answer will be k pi plus 1 equals to minus 1, because value of cos pi is minus 1. So by taking that minus 1 on that side, plus 1 on that side, it will be minus 1. So value of k pi will be equals to minus 1, that is equals to minus 2. So if k pi equals to minus 2, and if we need to find out k, then value of k will be equals to minus 2 by pi. So that's it. Now question number 30. Question number 30 is important one for 3 marks. In board examination, the weightage of this chapter till 2019 till 2020, it was 8 marks. 3 MCQs, 1 question of 2 mark and 1 question of 3 mark was asked in the examination. So for next academic year, the weightage will be also same, that is 8 marks, and this type of questions will be there in your examination in 3 marks. See what is given here. It is given, find the value of a and b if f is continuous. See here it is only given that f is continuous, points are not given. So what we need to consider, f is continuous at all the points. F is continuous for all real values of x. Here function is given that f of x equals to 5 whenever x is less than or equals to 2. F of x is ax plus b whenever value of x is in between 2 and 10, and whenever x is greater than or equals to 10, function is 21. So first of all we need to think about given points. Here we can clearly see that value of x is given in 2 different points. First point is 2 and second point is 10. So we need to take that 2 different cases. First of all we need to take function is continuous at x equals to 2 point, and secondly we need to take that function is continuous at x equals to 10 points. So we can solve it easily. We are taking function is continuous at x equals to 2. So left hand side limit of function and right hand side limit of that function both must be same. So limit x tends to 2 plus f of x. Here for 2 plus f of x it will be ax plus b, and for 2 minus f of x it will be 5. So ax plus b equals to 5. By putting that limit of x, here value of x tends to 2, that means ax, that means 2 into a plus b equals to 5, give that equation number 1. Similarly, if we are going to take function is continuous at x equals to 10, that left hand side limit, right hand side limit and value of that given point all must be same. So limit x tends to 10 minus ax plus b, that is equals to 21. So by putting value of x, it will be 10a plus b equals to 21. We got equation number 2. Now we can clearly see that in equation 1 and 2, two unknown values are there, that is a and b. And if we are recalling our 10th standard, then we have the simplest method to solve these equations is elimination method. In equation number 1 and 2, coefficient of b, that is 1. So we are going to subtract both equations directly. So what we are going to take, 10a plus b equals to 21 and 2a plus b equals to 5. By changing the signs of second equation, it will be 8a equals to 16, that means a equals to 2. By putting value of a equals to 2 in either one equation, suppose we are putting in equation number 1, then we can easily find out the value of b, that will be equals to 1. So that is nothing but very easy chapter, very easy topic, that is known as continuity, and there will be always one question from this chapter will be asked in your board examination or Gujket examination. Thank you.